We've heard a lot about AI, but what do we mean when we say AI or artificial intelligence? I will describe what it is and some methods used in AI. When we hear the term AI, most people think of the movie Terminator starring Arnold Schwarzenegger, where Skynet tries to take over the world. This paranoia of AI taking over the world is expressed in many sci-fi movies. Another example is I, Robot, starring Will Smith, made from a number of Isaac Asimov sci-fi short stories from the 40s and 50s. Any scientific enthusiast will remember the 3 laws which attempt to prohibit a machine takeover. A robot may not injure a human being or, through inaction, allow a human being to come to harm. The second law, a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. And the third law, a robot must protect its own existence as long as such protection does not conflict with the first or second laws. These robots have what is called self-awareness or a consciousness. These are futuristic types of AI that do not exist. There is no need to worry for now, as this level of complexity is far beyond today's capability. So what is AI? This is when a task normally performed by a human, requiring some level of intelligence to accomplish, is then given to a machine or software program to perform. That machine or program would require some level of AI. AI is where a machine simulates human intelligence processes. These processes are acquiring and storing of information, algorithms to utilize that information, and logic to provide useful recommendations or suggestions. The goal of AI systems is to exhibit some of the behaviors associated with human intelligence. Today we are seeing an AI explosion of speech recognition, translations to other languages, turning on and off devices, face recognition, and machine vision in manufacturing, to name just a few. AI systems can be placed in categories of either weak AI or strong AI. Weak AI, also called narrow AI, is a system designed and trained for a very specific task. Expert systems are in this category. Examples of expert systems are medical or dental assistants that can diagnose and recommend treatment. Strong AI, or artificial general intelligence, exhibits very broad human intelligence abilities. This type of AI can find solutions to a wide variety of tasks based on previously acquired data and experience, such as operating a spaceship. This brings us to NLU and NLP. NLU, or natural language understanding, is the machine's ability to understand what we say and what we mean. This is required because humans have numerous ways to say the same thing. Words are pronounced differently, we have different accents, we improperly use grammar, articles are often dropped, or expressions are used. Although humans can understand various ways of saying the same thing, this is challenging for software programs to understand what a person actually wants. Natural language processing is comprised of layers of systems working together to understand communication between machines and humans and respond to humans in everyday natural language that the human will understand. What is machine learning? Machine learning is where huge amounts of data are fed into a computer system, which the software program utilizes in learning how to perform a task. There are 2 types, unsupervised and supervised machine learning. Unsupervised learning is where algorithms identify similarities in the data that can be used in categorizing that data. In contrast, supervised learning uses online workers to label large numbers of examples which are used to train the software. I'll discuss what labels are later in the video. Let's discuss neural networks. Neural networks use the human brain and nervous system as a model to create the way a computer system operates. These interconnected layers of algorithms feed data into each other. The software can be trained by applying different weights of importance to the data as it passes between the layers. Applying higher weights to a specific inner node will have a greater effect on the output, and lower weights will have little effect. To properly carry out a specific task, neural networks need to be trained. To achieve this, the weights are modified until the desired output is reached. Deep learning means to learn data representations, which is different to creating algorithms that are designed to accomplish a specific task. Neural networks are expanded by numerous cascading layers of nonlinear processing units. They are trained using massive amounts of data to extract the features. I'll discuss what features are later. Labeled data means samples that have been given one or more multiple labels. Labeling data means that we apply meaningful tags to the data. An example of labels would be this photo that contains the labels dog, lake, or mountain. Feature learning allows a system to automatically discover the representations needed for feature detection or classification from the data. This replaces a manual feature determination and allows a machine to both learn what the features are and use them for performing a task. In this image, where one of the labels was dog, a feature might be eye color, fur color, or type of dog. Thanks for listening.